connecting with us. So just give me a few minutes so that we can proceed with all members and they can join properly. Thank you. And good evening, everyone. Okay, I think enough participants are right now joined with us. So, good evening, everyone. And just right now, I got a message in chat box that we are using Chinese component which we are purchasing from Amazon. Is it reliable or not? Or why we are purchasing that? How we can say this is our own technology? Actually, yes, that is a point we have to discuss. Means if we are purchasing, for example, the Node MCU I'm talking about, or the microcontroller I'm talking about, all kind of controllers is developed in China. That is the true, that is fact. But the point is that right now we don't have a proper facility that can process the semiconductor for us. That is the biggest issue right now we are facing in India. Okay, everyone knows there is a shortage of silicon in electronic market. Means we don't have proper amount of semiconductor right now to build these type of things. On the other hand, the technology which we need to build these things are very costly. The raw material is Jai Hind, Jai Hind, Jai Hind, Jai Hind, Jai Hind. Thank you so much, Santosh ji. Jai Hind. Yes. So that is the issue we are facing right now in this era. In this era. So our scientists, our government is putting some effort so that they can bring a facility so that they can build their own semiconductor. We can build our own microcontroller. Technically, if in general terms, I'm going to speak for you that if I'm talking about a microcontroller, building up a microcontroller means manufacturing of a microcontroller is very cheap, because the raw material, that the silicon that we are extracting from the sand is it's very it's very cheap process. But the point is that the process is going to be happen to extract that is costly. First point, that need very defined precision, the temperature, the doping process, and the pressure, and when they are mixing the doping element, so that the entire process is very critical. And after that, when we are integrating components in it, that is also a very difficult task. I don't know that you saw the facility where they are manufacture chip, means the integrated circuit. The facility is just like a space station. Each and every person has to wear a suit, so that not a single particle of hair or single particle of skin should be present over there, or not a single particle of dust has to be over there. If any kind of dust particle, any kind of moisture is present on that room, so the wafer, the silicon wafer they are going to make, that is going to destroy. It could be the entire batch is going to be destroyed. That is the point. That's why still we are purchasing the hardware from China. They are manufacturing it, and in some cases we are purchasing from USA also, Taiwan also. But technically, in general words, we know the China is the one of the biggest manufacturer of semiconductor products. That is true. Request to share feedback form possible. I hope the team could send the feedback form. So I will send the request to the team so that they can forward the feedback form. Okay. So that is the point, and that is the answer for the query that generated by someone. That's if we are purchasing a Chinese product from Amazon, so how we can say that this is safe or not going to hack? So the thing is that we are going to put our own software in it. The microcontroller is blank, the chipset we are going to purchase, that is blank. You are going to flash the entire hardware first, then you are going to put something in it. So it is very much possible that there is nothing a residue program over there. But yes, in terms of flight controller, in terms of a chipset that having already a BIOS program in it, yes, it's having already a BIOS program in it. So yes, there could be some kind of bug, but the thing is that we can rectify it also. Means if we have a team of software developer that they can refresh the entire BIOS of that chipset. So yes, what you're gonna do, you just purchase the empty hardware, just put your own entire software in it, and now you're good to go. No one gonna hack your system. So that is the thing which we can do right now. So technically, the point of this session is, the main point of this session is, we are going to put awareness in between faculty members that why these technologies are booming right now. What are the aspect ratios that we have to think for future, that within 2 3 years that we are going to see that a drone has to be in a subject, it's going to very soon. That's true. IoT is already in a part of our BTech subject. And the most important thing, still we are exploring the area how which we can create these things, how we can boost up these things. So that is the point of this session, that we can generate a awareness. Everyone know about that. If I'm talking about technical session, if I'm talking about a technical session where practical is also involved, okay, everyone know about the theories. I know everyone know about theories, that yes, this is that point, and this is going to work like this, and that's going to happen like this. Everyone know about that. But the issue is that we couldn't practice on a practical phase. Is it going to work like this, or there is something we need to understand first before we are going to implement on a practical phase? That is the point. So while we are actually, all the faculty members know about lots of things, we consider about that. But the point is that when we are going to put these things in a practical phase, we are going to face a lots of problem over there, because in theoretical things are little bit different. While we are doing the practical, the elements are going to be changed. Okay, you have to face lots of problem in most of the case. When you are going to put a hardware, it's not going to recognize by the system. Then what will you do? For example, you have a drone, you are going to make a drone, you put all the hardwares together, you put the flight controller, you did a good job, your all connections are good, you calibrate the drone properly. Now you are going to put the instruction in the flight controller, and while you are connecting the flight controller with your computer, on that time now you see the flight controller is not detecting. Everything is going to be dumped right now. Then what you want to do? Now you have to reverse engineer the entire process. That is the thing we have to understand. Then you somehow we saw some videos on YouTube. We research about it. We read some user manuals that okay, fine, we need to install this driver and we need to do these steps. And after that, what you want to do when you are going to fly the drone? Now you see the drone is not stable. Or you are when you are building an IoT system, then now you see the IoT system is not triggering properly. Okay, so if I'm talking about a system, it's having lots of element, lots of components which is working together. The more components, more complexity, and more chances of error on that place. So what we need to do, we have to prepare ourselves before we are going to building that system. Why? Because we need to save the time. If we are going to reverse engineer each and every step, then what will happen? We are going to lose lots of time and lots of effort. Then what will happen? Everyone knows that we have lots of tasks in our home also. So on that time, what we are going to think that, okay, fine, let's see, the entire project is going to delay or we postponed it. Okay, fine, let's see what's going to happen with it. Okay, so to avoid these things, to prepare that if this problem is going to happen, how to solve it, we have to understand as expect that yes, we know about that point. If we are going to face that problem, how to rectify it, how to solve it, and how to do the troubleshooting. That is the point of this session. Okay. All right. So I hope we have lots of participants right now. So let me start the session for you. And yes, we are going to do one more thing. I already told you that we are going to build the IoT hardware once again for you. But right now we are going to build with lots of devices. Feedback link share in WhatsApp kindly. Okay, I hope the team member can get the message. They will send the WhatsApp, they will send the feedback link to the WhatsApp. I hope so. Okay. All right. Let's start with the topic. Let's go. So right now, in a end of the drone session, we need to understand few things before we are going to talk further about the IoT. First of all, the thing I need to explain you, that is the PDB board. Okay. For example, if I'm talking about this frame, this is the frame. All right. If you want to pick a frame, is it possible that we can build our frame? Yes, that is possible. We can build our frame, our own frame, we can build. But the thing is that what kind of material we have to use? Most important thing, what dimension we have to put in it. And if we are going to build a drone, what should be the point we have to understand first? So technically, there are few frame already available in market. You can purchase that. For example, if I'm talking about this frame, this is known as S500. This is a carbon fiber frame, very light in weight, that you can purchase. If you don't want to purchase that frame, you can build it on your own. How we can build the frame? First option is we can go for the 3D printing. Okay, that is the first option, that we can go for 3D printing. But in most of the case, I know we don't have the 3D printer also. So what we can do on that time? We can go for a wooden frame also. But we have to make sure the weight of the frame should not be more than half kg, means 500 grams. Okay, why? Because if you are going to increase the weight of the frame, then we are going to fix the different component in it. The entire weight of the drone is going to be high. That we have to understand before we are going to build our own frame. Okay, so now the point is that what kind of material should be best for building drone? Aluminium sticks. Okay, technically it is known as aluminium channels that you can purchase from any hardware store. But the point is that how we can measure the drone is correct. So the thing is that if you are going to make a quadcopter, okay, so technically the quadcopter should be in a two format that we can use right now. It could be in a plus format or it could be in a cross format. So if you are making any one of them, the thing is that the distance between all the four motors has to be same. Okay, means technically if I'm talking about, it has to be make a square box. That is the one of the easy design that we can build. Okay, that is the point. Means if I'm talking about all the motor placing positions, it has to be a same size. If I'm talking about, means same gap, if I'm talking about from this one to this one, or if I'm talking about this one to this one. Okay, so my side network problem. Okay, I hope everyone getting my screen and voice properly. My voice is clear to everyone. Okay, okay, thank you so much. All right, clear. Okay, thank you. So yes, thank you so much. So right now we are going to understand one more point. Okay. So the thing is that now if we are building a drone with either an aluminum frame or a wooden frame, we have to make sure few things. If it is an aluminum frame, we cannot leave any kind of open connections or any wire that doesn't have any kind of insulation. We cannot use that over there. Because if it is an aluminum frame, there are lots of wire and lots of components is going to tie with it, with the body. Okay, so on that time, we have to make sure each and every wire has to be insulated and tied properly with the body. That is the point. And if we are using a wooden frame, then we have to understand we need a board which is known as PDB, Power Distribution Board. What is power distribution board and why we need that? Technically, if we are building a drone frame on our own, we need the PDB. Okay, because the PDB is going to distribute the power. How the PDB is going to distribute the power? Let me show you first. There it is. See, this is an image of PDB. Which one is the PDB? Let me explain for you. Technically, that is PDB. Just give me a second. Okay, that one is PDB, this part. This one is PDB. Okay, let me zoom this for you. That I already show you in a previous session, but I'm going to explain it over here. So what's happening here? If I am representing this board, it's having some points. What point I'm talking about? Connecting points. Okay. Number one connecting point, number two connecting point, number three connecting point, number four, and there is one more connecting point over here. So technically what these points are going to do, we have to understand one thing. These points are used to fix the ESC on it. Means the power lead of the ESC we are going to solder over here. Okay. Similarly, this is for example ESC 1, this is for ESC number 2, this is for 3, and this is for 4. Okay. Technically, this is the quadcopter frame, means quadcopter means 4 motor frame. So it is going to give you 4 points to connect 4 different ESCs for different motors. That's it. And that part is for the battery. Okay. But don't worry about it. So all mounting and soldering points are in the same plane. If I'm going to put the battery over here, it is going to short? No, that's not going to happen, because this point is connected like this. Sorry, just give me a second. It is going to be connected like this something. Okay. Okay. So what's happening on over here? It is going to give us a connection to the selective point, and that part is going to connect with these points. This is dual side board. Dual side board means the back side is also having tracks. So in one side it is going to give you ground, and the other side it is going to give you the positive. So it is not going to short, it is not going to damage anything. It is going to distribute the power to different ESCs. Okay. So how should be the connection that we have to done? There it is. Just give me a second. Let me bring it front. There we go. All right. This is the thing. So over here, we are going to see all the connections that we can perform. This is the section where we are going to put the power supply for the ESCs. Okay. These are the power supply point for the ESCs. And over here, we have the battery connection. Simple. Okay. And similarly, but in case of three wire ESC, how we can connect? Okay. I need to clear the confusion. Listen up. If I'm talking about a 3-wire ESC, so the 3-wire has to be over here. Just give me a second. I need to change the slide for you so that I can explain it properly. If I'm talking about 3 wires, then it should be over here. Just give me a second. There it is. Now you see. Okay, I need to zoom out this. See. I have not received feedback form link. Okay. I think just someone shared the feedback form link. I think it's shared on the chat box. Okay, so over here. So as you see, we are talking about, it is on the chat box, I think. So it is this power wire we are talking about. The power wire always 2. Okay. The power wire always been 2 means first is negative, another one is positive. Okay. And if we are talking about the 3 wires or the 2 wires, it will be like this. Okay. These are the connecting wires. So it's all about the signaling wires. It is not going to connect in the PDB. Okay, it is going to connect in the flight controller. That is why PDB having only two wires for the power supply. Okay, thank you. So now we are going to proceed for the next point. So there we go. All right. Now we are going to talk about one more thing. That is a very crucial and very important point. We connected all the ESCs, for example, means all ESCs connected. We connected all the motors with the ESC, but still we have to do one more thing. We need to calibrate the ESC. Without calibrating the ESC, if we are using Shimong firmware ESC, with that we have to understand. If we are not going to calibrate the ESC, then what will happen? The RPM of the drone motors are not gonna same, or the drone cannot control the RPM of the motor properly. Why? Let me explain this first. If I'm talking about this ESC, okay, for example, this one, the first one, okay. In the first one, this ESC, it's having its own memory also. Means a small flash memory is present in this ESC where it can store some data. What kind of data? It is going to understand the throttle first. Means what should be the signal when the throttle is 0, and what should be the signal when the throttle is in 100%. What is throttle? Throttle means the stick, means the joystick which we are using. Okay, that we have to understand. For example, if the stick is 100% down, means no throttle is over there, it is going to generate a PWM signal. Or on that time, when we are going to push the throttle at 100%, the width of the pulse is going to be changed. On that time, we have to tell the ESC that yes, this is at the zero throttle, this is at the zero throttle, and this is at the full throttle. According to that, the ESC is going to change the RPM of the motor. That is the first point. In the case when we have ESCs and these are not calibrated, on that time, the flash memory present in the ESC is having different kind of data in it. We have to tell each and every ESC. First, we need to fix all the ESCs together. Then we are going to connect the ESCs to the flight controller, and then we are going to start a calibration which is known as ESC calibration. That is one of the most essential calibration we have to perform. In this calibration, we are going to tell each and every ESCs at the same time that this is the lowest throttle you have to learn, and this is the highest throttle or the full throttle you have to remember. Now when the ESC is going to get these informations from the flight controller, now they can work synchronously with each other. That is the most important point we have to understand. If we don't calibrate the ESC, then what will happen? We are putting a little bit of throttle, the drone is going to fall in a certain direction. Okay, that is the fault we are going to face in it. If we are using Shimong ESC, that is the thing we have to understand. If we are using advanced ESC, means talking about Bell-Hel firmware. In Bell-Hel firmware, we no need to do the ESC calibration, because in some case, if we are talking about the high-end ESCs, they are going to, in a set, when we are put the flight controller in calibration mode, they are going to get the data from the flight controller and they don't need any kind of calibration settings. That is the thing we have to understand. So Technically, in 90% cases, we are using the Shimong because that is easy to available and it is cheap. That is why we use Shimong. That is the thing. So on the time we are using Shimong, remember one thing: before flying the drone or before anything, we have to calibrate the ESC. That is the step number one we have to follow. All right. So next we are going move forward to one more step, that is the flight controller calibration. How to calibrate the flight controller and how to tell the flight controller what to do and how to do. Okay. So let's move forward towards the flight controller, and let me change the screen for you. And we need a different software right now. Just give me a second. I need to open a different software. So just give me a second for you. There it is. There you go. Got it. I hope you can see the screen. Okay. So this is the flight controller software I'm talking about right now. So in this flight controller software, we have to understand the point that this is the first interface of the flight controller. All right, it's okay. What it's going to represent to us right now, we see few important points that we have to consider. This is a DJI flight controller, DJI M-Lite. Okay, means this is the M-Lite flight controller flow for M-Lite. Um, M-Lite. This is the M-Lite flight controller software. Actually, means we are going to put all the settings from here. But the thing is that how we can operate this. First important point we have to understand. If we are observing, there are two red and another is blue dot is present at the bottom of this software. This represents the drone is connected with the software. If the drone is connected, it is okay. If the drone is not connected, the light is turned off. It is off right now. So what I'm going to do, I'm going to turn on the drone and going to plug in the drone so that you can see how it is going to look like on that time. So just give me a second so that I can put the data cable to the drone. And before I'm going to connect the drone, I need to power on the drone also. Before turning on the drone, I cannot put the data over there. So what I need to do, I need to first power on the drone. All right, I just put up the drone. And now I'm going to connect it with the system. Okay. Is the screen visible to everyone? I hope you can see it. Is the screen visible? Is there any kind of interference or something like that? Yes. Okay. Thank you. Thank you so much. So right now, what we have, yes, thank you. Thank you so much. Now we see that over here, the blue light is start blinking. Means the drone is communicating with the software. Yes, the drone is communicating with the software. So right now what we have, these are the channels for the motor. And I hope everyone can listen a voice, also able to listen a voice, beeping voice. That is the voice from the BLDC motor, which is beeping right now. Okay, it is checking the motor is activated right now, means the signal is constantly throwing to the motor by ESCs. So let's do this and let's understand how to calibrate this software. I need to open the remote control also, because without the remote control, I cannot show you how it look like. Just give me a second. There we go. So all right. Now you see the time when I turn on my radio device. The radio device is turned on. Okay. When the radio device is turned on, now you see I got the signal in each and every control points over here. So what's happening right now? Now you see I'm going to put the throttle at the maximum point. Now you see the throttle is increasing. This is the throttle point. Okay. This is the throttle point. Okay. One more thing. Technically, if I am speaking, how what kind of throttle system we have. If you see this in camera, okay, I hope you can see this in camera. I need to turn off the screen share. If you see this remote, we have that is for the throttle. Okay, remember this. And when I am pushing the throttle and leave it, it is gonna put at the center point. So this remote is means that mechanism is known as central throttling system. Means when I am gonna leave this point, it is going back towards the center. Why we use that kind of remote? Because when we are using a drone which having altitude holding or altitude stability mode, means self level mode, on that time we have to put the throttle at the center. If we need to lift the drone up, we need to push the throttle at upward direction like this. We need to push the throttle upward direction like this, just a little bit. The drone is going to be increase its altitude. And if we want to decrease the altitude of the drone, we need to slightly down the throttle and it is going to back to the altitude very slowly. And if you want a vigorous movement, you can increase the throttle movement like this. Okay, then the movement is going to be vigorous. So let's talk about the software setup, how we can do that. So let's back to the software. Over here, we have to understand one more point. Now I'm going to tell you few things. If the stick is not in center, remember, if these sticks are not in center, for example, it is moving over there and something is appearing like this. Okay, so what we need to do? We need to start the calibration from the remote to the flight controller software. That is necessary. Okay, how we can do that? Let me explain. First of all, we have to make sure all the throttle settings has to be at its initial position. If it is, if these settings means if you have a central throttling system, then means central sticking system over there, then it has to be in central point. That is the first thing. Then you have to do one thing, that when we are talking about the channels, I hope you can see these channels. Okay, these are the channels. These channels should not put any kind of value on that tag. If it is appearing any kind of value, I saw it on, I represented on the camera. So if it is representing any value, you have to calibrate in the remote first. It has to be 000 from it. Okay. Then we have to perform the settings in our software. How we can do that? Let's understand these things. Okay. So first of all, let's understand what are the controls of this drone. Starting with the throttle. Okay, we are going to starting with this the throttle. This is throttle. If I'm talking about throttle, if I'm increasing the throttle, the drone is going to, sir, I think some bell sound coming from your, yes, the bell sound is coming. It is from the drone. This sound is from the BLDC motor. Okay, if I can able to see, represent on the screen, just give me a second. I need to show you one more thing, everyone. You see, these fan blades are moving constantly. Just give me a second. Let me rotate the drone. See, See, okay, they are making this sound. Means right now the drone is powered on and the data cable is connected with the computer. So when you power on a drone and the ESC is connected with the BLDC motor, it is going to make that sound. Okay. So right now we are going to talk about the movement. Okay. So what movement I need to show you? Listen up one thing. Over here, this part is for the throttle. This part is for the yaw or rudder. This is the movement, means if you want to move it forward, if you want to move it left and right, means elevator and aileron. So now we are going to understand one by one how these control settings we have to understand and how they are going to work for us. Okay, that's the thing we have to do. So let me back to the controller screen. There we go. So right now I'm going to talk about the first setting, that is throttle. If I'm pushing the throttle switch, now you see the drone is going in higher altitude. And if I am pushing the throttle switch in downwards, now the drone is losing the altitude and coming towards the ground. All right. If I want to rotate the drone on its own axis, that is known as rudder. Okay, that is known as rudder. We can do this by pushing the throttle stick left and right. Okay. Similarly, we have elevator. Elevator means, if you see in the camera, if I am pushing this switch, this one in forward direction and in backward direction, then what's going to happen if I'm pushing the switch like this, elevator, pushing the elevator up, the drone is going to move forward. And if I'm pushing the elevator in backward direction, then what will happen? The drone is going reverse, means in backward direction. And last, the aileron. So what's happening here? If we want to, why blue LED is blinking? Because the drone is sending these data. Means right now I am sending the data to the drone, and the blue light represent the data communication between the software, means this PC, and the drone are communicating with each other. That is why blue light is blinking right now. It representing the data communication. So if I'm talking about aileron, then what will happen if I'm pushing the stick in left side, then what will happen? The drone is going to move on left direction. And if I'm pushing this stick on right direction, the drone is going to move in right direction. And there is one more thing. There is a auxiliary switch, which I am representing over here. This is for the gimbal. And one more switch is for the different flight mode that we can select. Right now it is representing I am working on manual flight mode. At the bottom you see the mode option is appearing. It is in manual flight mode. When I'm shifting, now you see it is in an altitude hold mode. This is known as altitude hold mode. Now how we can set this setting? Let's begin with it. So let's go to the basic option. Where it is? There we go. So now we are going to understand how to set up a drone one by one. Okay, how we can put all the information to the flight controller very easily in simple words and terms. Let me turn off the drone. When I'm going to turn off the drone, now you see what will happen. Right now you see the blue LED is blinking. Okay, when I'm going to disconnect the power supply, now you see everything has been disconnected. Okay, everything has been disconnected and the sound has been stopped. So now we are going to understand how we can calibrate a drone. So first of all, we have to understand how many type of frame do we have here in this flight controller. We have few structure of frames available. This is the quadcopter in plus mode. This is in X mode. Similarly, this is the hexacopter in plus mode as well as cross mode. It's having a tricopter in a balance wing in front base, and another, the balance wing is on the back of the drone. But if we are talking about what should be the best, I think the screen has been gone or what? My video is available. Can you see me? Means the screen and the audio is available, visible and audible for you? Okay, okay, okay. It's visible. Thank you, thank you. That I want to know. Thank you. So first we need to select what kind of drone we want to build. Okay. So right now we are going to build the quadcopter in X mode. Why it is in X mode? That is the most stable design that we can go for it. There are few more designs that we can use. Means if we want to make a hexacopter, then we can go for this one. Means this is the hexacopter design that we can use. This is also a most stable design that we can apply for our build. But right now we are using the quadcopter X mode. Okay, you have to select the frame that you are going to build. That is necessary. So select the frame that you want to build. Then I'm going to talk about the mounting. Mounting means where you are going to place your flight controller. Now listen up the point very carefully. Means plus and X mode design looks same when the okay, just give me a second. No, in plus mode and X mode there is a very huge difference. What is the difference? First we have to understand. See, if I'm talking about a plus mode, if the drone want to move forward, okay, listen up this point. That is a very crucial point. If I'm talking about a plus mode, let me bring a pencil also. Is it possible that I can put a pencil over here? Yes. So if I'm talking about plus mode and I want to move the drone in forward direction, then we see there is only one motor that is going to give me the thrust so that drone can move in forward direction. Okay. Similarly, if I want to move left and right, there is only a single motor is going to act on that time. But if I'm talking about X mode, if I want to move the drone forward direction, you see there are two motors is going to act for this. Means the maneuverability and the speed and the power of the movement we are going to get in a X mode rather than in plus mode. That is the drawback between plus and X mode design. But in any case, if you want to make the plus mode drone, you can go for it. Where we use the plus mode drone? When we are making a hybrid fixed wing drone, on that time, what we can do, the body of the airplane is look like something, and then you can go for the wing like this. Okay. So on that time, you can build the plus mode inside an airplane so that without a runway it can fly, and then close this, you can turn off these motors and the jet propulsion or any different secondary motor system can start working so that the plane can gonna fly forward. And if we are going to talk about a plain drone, means a pure drone system, according to me, the X mode is one of the best mode that we can go for, either in quadcopter or either in your hexacopter. And this is one of the stable design also. Means it is having a very stability while it is a windy means a windy region you are going to fly. So that is the point we have to understand. I hope you can get this thing. So let's talk about the mounting. Mounting means where we are going to put the GPS respect to the flight controller. That is the very crucial thing. Means the location of the GPS in the drone, we have to give the exact coordinate, means X, Y, and Z coordinate we have to tell at which position we are going to place our GPS. Why? Because according to that, the drone is going to rectify the data of GPS. Means, for example, the GPS is little bit shifted and we need to lock the drone in certain position. Then what will happen if the GPS is in a position, the drone thought that okay, fine, my GPS in a right position means I am in a right position, now I can drop the payload. But the body of a drone is shifted from the location, means we cannot get the pinpoint access or the pinpoint accuracy. To get the pinpoint accuracy, we need to tell that the GPS is shifted from the center of the drone that much amount and we need to put it over there. That is very important point we have to understand while implementing GPS in it. Why we need a GPS? That there are two questions. First, why we need a GPS, and is it possible that we can make a drone without a GPS? Yes, we can make a drone without a GPS. What side effect we are going to get? There is just only one side effect, that we cannot get the position hold or RTL. Okay, means we cannot get the RTL, return to launch mode. That mode is not going to work. As well as we cannot go for the mission planning. Mission planning means if we want to put some coordinates that you have to go over there and there and there, we cannot do that because the drone don't have the GPS. Without GPS, it cannot find its coordinate. That is the point. Similarly, it is not going to hold the position. Position means if I am holding I am flying the drone in a GPS mode, then what will happen? I put the drone in a certain place and leave the remote. Then what will happen? The drone is going to fix in a certain position. It's not going to move. Either you are going to pull the drone, either you are going to push the drone. If you push the drone, it is going back and stable on its own position where you place on it. So that is the thing we have to understand about GPS. Now this is the RC. That is the vital part we have to understand. This is known as radio calibration. So technically, I'm not going to put you in a deep point. I'm just give you the overview so that you can understand how these things work. When we are building a new drone or a new build, we have to do one more thing, which is radio calibration. This is the, someone called it RC calibration, someone called radio calibration, someone called remote calibration. Great things to learn. Thank you so much. Thank you so much. I'm just trying to give you all the points that you have to understand. So this is the radio calibration we have to do. What is radio calibration and why we need to do this? First of all, first we have to understand the receiver types. What kind of receiver we are using? Is it a traditional receiver? Is it a D bus or it is a PPM? So first of all, you have to know what receiver you are using. If you are using a normal receiver, then you can go for the traditional. And if your receiver having a PPM, I'm not gonna put you in a deep point that how the D bus work, because there are S bus, D bus, and I2C communication. There are lots of type of thing. Okay, but in short, there are different type of receiver that we have. So you have to select first the type of receiver you are using. In general words, if you are using lots of wires, that is going to put in your flight controller, it means you are using the traditional one. Okay, do receiver frequency and non-different technology? Yes, yes, definitely. If I'm talking about a receiver that is used by defense or a military gate, they are having way different than a receiver which we are using. Their frequency is different, their modulation power is different, even though their operating range is very different. Okay, so that is the thing. Okay, next we are going to understand how to calibrate these things. What is the necessity of calibration? We need to tell the flight controller that in this remote, that is the maximum point, and that is the minimum point of the stick. What I need to tell you about stick, just see. This known as sticks, okay? We called it stick. Okay, just like a joystick. So these are the sticks. Okay, so we need to tell the flight controller if I'm pushing this in full and if I'm pushing this in a 0 point. It is going to give you a certain PWM signal. Then what you need to do, you need to tell the flight controller, if I'm pushing this in a maximum point, that is the maximum PWM signal is going to generate. And if I'm putting it on a 0 point, that is the zero, means this is the minimum PWM signal, means the minimum width of the signal is going to generate. So technically we are going to start one thing, that introducing this remote control to the flight controller. What's happening on that time? The flight controller is going to understand this remote and understand the signal that yes, that is maximum point, that is minimum point, and that is center point. Then when you are going to start flying the machine, flying the drone, now you are going to get a stable and a safe flight, because they know if you are pushing a stick a little bit, you calibrate your ESC already, you done the remote calibration, you put the drone in a right format, means yes, I am using a Xcopter or hexacopter, what design you are preferring. If you are having a GPS, then put the measurement of the GPS over there. Let's talk about the PID settings. So if I'm talking about DJI flight controller, you no need to change anything. They have their PID settings very good. And if you are using any different flight controller in which you need to put a PID settings on your own, just go for 50 to 60% first. Recommending 60 to 65, you have to start. Just fly the drone and feel how it is going to act on your command. If you feel that this is a laggy or not appropriate, means you are not getting the feeling that how we can change the max and minimum value during calibration. Okay, that also a point. I'm going to show it you, but it is going to happen with the remote. It is not going to do with the flight controlling system. Okay, so I need to show you in the remote how we can change the minimum and maximum point. So all right, so what we need to do, yeah, PID setting, post integral derivative setting. Always recommended that start with very low PID settings, because low PID setting make the drone laggy. If you pull the stick a little bit more, you know you are not going to crash the drone. The drone is going to be like this. I'm very lazy drone. It's going to show you, okay, fine, I'm very lazy drone, I'm not going to act on your command. So on that time, you need to increase the PID setting 5 to 10%, step by step. Don't do that, okay, 80% is not going to work, let's do 120. No, don't do that. Just increase the PID setting point by point, means 5%, 10%, like this. Because the PID settings are very aggressive setting actually. If you put a wrong setting on it, then what will happen? If you put the throttle, and drone is gonna, just like a rocket, is shoot gonna sky. And if you want to drop the drone, means if you want to the drone should have to come back. If you put the throttle in downward, then what will happen? The drone is start falling, because the motor is going to stop on that point. That's why I'm saying put the PID settings in minimum point and then increase it very slowly as per your flight and as per your experience of the flight, that okay, fine, I am good with that. Okay, and if you are using DJI NASA flight controller or DJI flight controller V2 or any different flight controller, you no need to worry about it, because the PID settings is very good in it. So it's done. Now let's talk about few more things. That is the basic calibration we done over here. Now we are going to talk about the motors setting and calibrations. Let's understand. What is it? Motors, recommending and cutoff, what is it? This shows that motor ideal speed. What should be the motor ideal speed? First of all, we have to understand what is motor ideal speed. If I am flying the drone in altitude hold mode, then what will happen? The drone is still placed on the ground. I arm the drone and put the stick on a center mode. The motor of the drone are start. We need to push the throttle and drone is going to be lift. On that time, the ideal mode, the RPM of the drone has to be considered. So on that time, if you want that the drone has to be very smooth and very gentle, you have to go for low speed. And if you want that drone has to be aggressive and boost it like a rocket, so you have to put the ideal speed in higher mode. Now, what is cutoff? Technically, there are two type of cutoff we are going to talk about. First of all, we are going to talk about a remote communication cutoff. Remote communication cutoff means, for example, if you put the drone in a certain location where the remote communication has been disconnected in any reason, or somehow you drawn out with your battery, then what will happen? If the cutoff is immediate, means all of a sudden the motors are gonna close and the drone is going to fall. And if it is in an intelligent mode, then what will happen? The chipset present in the flight controller is going to land the drone on its own. Okay, remember one thing, there is RTL method also. RTL method means if we put the GPS in it, means the GPS is available over there, then what will happen? You can go for RTL also on that time. Means if the remote communication has been dropped, then the drone is going to come back on the position where you launch the drone. That is RTL. But if you don't have a GPS, then what will happen? The drone is going to start landing very gently on its own. You don't need to do anything. You need to just do one thing, just ran towards the drone so that no one else can pick your drone and run away. Okay, that you have to do. Okay, now this is a fail safe. Oh, okay, one more thing. RTL and failsafe are same thing. Remember that. This is the thing you have to understand. If in some flight controller it is represented as failsafe, and in some flight controller it is known as return to home or go home and land. Okay, that is the thing. It means if the remote connection is disconnected on that time, either you want to land or either you want to go home and then land. So that is known as RTL or RTH. Okay. Now it is the IOC. So these are the home course, and if you want to lock some course over there, you can do that. But if you don't have a GPS, so on that time we cannot do this thing. So it is a intelligent operating system. Means if you are going to give some mission planning that you have to go in that location and you have to do this, so you can put it over there. Similarly, there is a gimbal setting. This is the one of my favorite setting. This is one of my favorite setting. Why? If you are going to purchase a drone from DJI, or if you are a person who want to travel, who want to record different locations, and if you are a nature loving person, so what you want a good camera. If you want the hobby of photography, means you want a camera, or if you want a drone, on that time you always thought that if I had a drone, I can get a top view shot and I can get these things. So if we have a gimbal setting in it, we can fly the drone and get the view from at a certain height of the entire location by the gimbal. Now, what is gimbal? Gimbal is a technically that is a part of component, but we have in a simple language, if I need to explain a gimbal is a device that hold the camera and while it is holding the camera by the help of motors present in it. BLDC motors is also used in gimbals. So by the help of these motors, any kind of jerk, any kind of extra movement has been terminated. Means the shot you are going to see from the camera is very smooth. You can't imagine that is recorded by the running person or a drone. You thought someone hold a camera and flew around the entire field or entire building. Okay, so that is the work of gimbal. Means no shakiness, no extra movements. So all the shots are gonna stable. So technically there are three type of gimbal is available: one axis, two axis, and three axis gimbal. So what is one axis gimbal? Means only the up and down movement, and two axis up and down with left right movement, and the three axis gimbal is going to help us that if it is going to move like this, and it is going to move like this, as well as the entire body is going to be means if the drone is going to shift, the upper body of the gimbal is going to hold you that yes, the drone is shaking like this, but the entire camera is fixed in a certain position. Means you unable to understand what's happening with the drone. Okay, that is the use of gimbal. So we can fit GoPro and we can fit different type of camera over on those gimbals. So it's very easy. One more thing, that is the biggest question we are going to face. So why we make our own drone? It's already available in open market. We can just go and purchase the drone and we just ready to fly. We can do anything with it. Yes, we can do that very easily. But when you are going to fly the drone, technically the to make the drone fly is not an easy thing. I'm telling you that is not an easy thing. If you having a drone, if you don't have a drone, just go and purchase a very cheapest drone available in the local shop and just try to fly the drone. Now you feel yes, that is a challenging task. First point. Second point, okay, you purchase a DJI drone and you say, sir, the DJI drone is one of the most stable drone we have. Agree, agree. But it is not possible that if you fly a drone for multiple times, it's not going to crash or nothing is going to break on it. On the point when you damage the drone, now you are in trouble because either you couldn't find the service center, and if you find the service center they give you a huge bill that the propeller is damaged, the entire motor is damaged, you broke the arm or the gimbal is damaged. Then what will happen? You having a huge amount of charge over there. First you purchase a costly drone, it could be around 1,20,000 around, and then you are going to give the a huge amount in service and repairing, and the batteries is also very expensive of those drones. Why don't we build our own? For example, if I'm talking about this drone, okay, I remember I dropped this drone from two-story building. Okay, what happened over there? A propeller was broken all of a sudden because I hit with a tree, and the entire drone was fall from a two-story building. What I did, I just collect all the parts, put it on the table, reassemble it, change the propeller, and it's good to go. If you build your own drone, you don't have any kind of issue with rebuild it because you already know how to build these things. Okay, you can fly, you can show off, you can do anything, and if it is damaged you don't have any kind of panic attack. Now I have to spend money. Okay, no problem. For me it's a matter of time. I'm just gonna fix the drone just within a 1 or 2 hours, and it's good to go. That is the point. And the cost you are going to put the repairing, it's very minimum. The propeller, it could be cost around 150 rupees. If I damage the propeller, I already have lots of propeller, so I no need to purchase it. I just need to replace and put a new propeller. That's it, that's all. So that is the point. Do you need to take permission to fly a drone in location? Yes, thank you to ask that question. It is very much possible. I just missed that point because I didn't thought about that. Yes, some places are restricted to fly. I consider it. That is very true. You have to search it on Google that which is a fly zone where you can fly and what is under a restricted or prohibited area. So on that place or on that area, you cannot fly the drone. But there is a catch for you. If you purchase a drone of any kind of any company, it could be Avita, it could be DJI, or it could be anything. When you are in a prohibited area, the drone cannot arm, the drone is not going to fly. That drone is not going to fly. Remember that. But if you build the drone, that is going to be fly. And one more thing, DJI drone cannot achieve a height more than 15 meters. Yes, 15, I think 15 feet. No, yeah, I think 15 feet or 15 meters, something like this. I'm just little confused. But DJI drone is going where the UNI number is required in every. Yes, 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 yes. Just let me clear the first point. If you build your own drone, you can fly at any altitude because there is no restriction software over there. And the thing is that if you build your own drone, it means there is no restrictive element present over there that gonna track your drone down. On that time, you can fly the drone at any altitude, at any location, if you build your own. Now comes, sir, how we can say this drone is a commercial drone and this drone is non-commercial drone. It will come under a toy. If a drone, it's all about the payload capacity. Means if the drone can lift a huge amount of weight, if a drone can lift a huge amount of weight, what kind of weight we are going to talking about? More than 2 or 2 kgs. Okay, so on that time, the drone will come in. Sorry, not only 2 kgs. If the drone is capable to pick 500 grams, it means the drone will come under a certain commercial range that you have to get, register the drone first, then you have to fly it if I'm talking about some legal aspect. That is the point. And if we are talking about a huge drone, so that's having a different rules and regulations. Means agriculture drones and the commercial drones, you have to first get the license to fly the drone, then you have to build, and then you have to register the drone that yes, this is the drone which we built, and now we are going to use the drone in a certain area, please give me the permission. Means this is the field where I'm going to use the drone for spraying water or spraying fertilizer. So that is the task we need to do with this, and I need permission to do that. We have to do this. Okay. So that's all for the drone. And let's go to the IoT session. Means let's talk about the IoT session. Screen share stop. Okay. IoT session means now I'm going to show you few things about the IoT that I already. We didn't remove the hidden see. What is it? Shubhendu, please let me in. Okay, okay, okay. I'm welcoming Mukesh sir. Sir, please join us and share some points with us, please. Is Mukesh available? Okay, okay, okay. Just give me a second. Thank you so much. Thank you so much. I'm trying to put Mukesh sir in right now, and I couldn't able to do that. It is representing me access deny. Why it is representing me access deny? You just give me a second. Okay, there he is. Mukesh.
Okay.
So do you have the voice right now?
Yeah, I believe
I'm trying to put you on the camera also. Actually, it
not an
is.
issue.
Yeah. It is giving me permission to talk is available, but how I can
Well,
give?
not an issue, not an issue. I think so.
Okay,
I'm
okay,
better off talking, so
okay,
don't
okay,
worry.
okay,
So,
okay.
good evening,
Please.
participants. On behalf of AICT Academy, IIT Kanpur, I welcome you all for the last day of the faculty development program. Um, First of all, let me thank all the participants. You have been, I mean, every day we had a full house. We had more than 500 participants on any given day, and that really speaks volume of the fact that the faculty members have liked the training program and they were looking forward to this. So we also already had a couple of suggestions. Somebody said that we should have a separate session on IoT and a separate session on drone. We are thinking about that. We are coming up with blockchain. We are coming up with signal processing and some other like faculty development in niche technologies. So I have with me, like, we are coming up with Python from 13 to 17, blockchain from 20th to 24th, machine learning, data science, IoT and drones, data visualization, advanced Excel, cyber security, blockchain again, Angular, MongoDB, so on and so forth. So we are actually coming up with lot many FTPs. So I hope it would have been a nice session. I mean, anything you wish to write, in terms of the feedback, you all have the feedback form. So you can actually, we would request all the participants to kindly fill up the feedback form, number one. And number two, we wish to have a feedback since I can't, if you can unmute yourself and talk to me, more than welcome. You can actually unmute your mic and have a word with me. And let me know how the faculty development program went and what have been your experiences, or you can actually write to me on the chat as well. I'm reading all the chats. I'll try and reply to you immediately. So, Puri ji, Raki Puri, one of the best FDP. Thank you very much. Princy Tyagi, fabulous session. Thank you very much. Thank you very much. Okay, right. I mean, though I've been into education for 25 years, even now getting a good feedback thrills me. It just thrills. So that gives us more power and energy to prepare for the next faculty development program. So let us have a quick feedback from all of you. I mean, all of you want to share a feedback with us, fair enough. And then I'll take you to a small journey as to what we are looking forward to and how we can associate with each other. So till the time we are getting the feedbacks, I'm reading also all of them. So if you wish, we can associate with your institution. We can do a workshop for your college students on any of the emerging technologies. It will be the workshop will be free of cost. Obviously, we will not be giving certificates to the students, but you can have a live workshop from our side anytime you feel like, and we'll be more than happy to come and deliver the workshop online live. Currently, in the last faculty development program, there are close to about I believe 48 colleges who have asked us to come and who have asked us to deliver the workshop for their students on emerging technologies. So if you wish to do that, please do write to us. I'm writing down my email ID. You can actually copy it down, and it's EICT at the rate iitk.ac.in, AICT@iitk.ac.in. E has to be small. I'll write it again. EICT@iitk.ac.in. So you can write to us. We'll be more than happy to come deliver a thing. So your college can also become a partner to us, like GH Rai Soni College became our partner for a big part, and a big number they have contributed. So you can also become a regional partner for us. You can become a local partner for us, because it is not possible for us to reach out to every college. So that's the best way. We need to help each other to reach out to more and more colleges, to reach out to more and more faculty members, and that is all we need in form of a guru dakshina, right? So like Dr. Fani, he always says that in Guru Dakshina, we are, as Eklavya, we are not going to ask you for your thumb. We'll need your help and assistance in percolating all the programs that EICT Academy IIT Kanpur is running to reach out to the faculties as well as the students. Uh, we'll also share with you on your WhatsApp as well as on the mail the summer training program that we are launching. So kindly circulate that particular WhatsApp in your students group. That's a request. Again, I'm making. Please ensure that your students are made aware of that. The student will have to pay the fees to IIT Kanpur directly. The delivery responsibility is taken by EICT Academy IIT Kanpur. And if they wish, they can come and stay also at IIT Kanpur. So you're starting the first batch on 18th of May, and will go till 16th of June. The second batch will start from 16th or 17th of June, and it will go till July 13th or 14th, as the case may be. And by grace of Almighty, I mean, we have a very good response. The type of response that we are getting, there is a possibility we'll have to stop enrolling students with us. So, you're asking for the fees. Currently, I believe we have given the students a discount of close to about 17.5% of the course fees. Course is pretty economical. The course range is anywhere between 6,900 to 15,000 or 16,000 rupees maximum. And we have courses like competitive coding, level 1, level 2, which, I mean, any tech company is charging an astronomical cost for that. We have data science, AI/ML, we have data analytics, we have cybersecurity, we have cyber forensic, and Python for machine learning. So we've got a lot many full stack development. So there are a lot of things that we are doing. But I mean, at the end of the day, if the message does not percolate to the students normally go out and do it. And a lot of trainings come with internship with companies, right? So it is not just a training. They'll do some project work also, and they will be awarded internship as well. So, next, Ravi, I believe I'll be leaving the session after 5 minutes, and Chubantu will be taking it over again. So, Hussain Saab, आपको अभी join करते रहना पड़ेगा. You'll have to be in the session. So, I spoke of 3 things. First is, please fill up the feedback form that we have submitted to you. You have got any suggestions, please write to us. We'll be more than happy to incorporate that, number 1. Number 2, if you wish to become our partner in faculty development program, do write to us. We will try and make you a partner. The partner college gets a certificate. The partner college coordinator gets a certificate that they have coordinated for the faculty development program. We'll share with you all the upcoming faculty development programs. And then you can actually do a workshop for your students that is free of cost. 2 hours workshop from IIT Kanpur. We'll deliver it online live. It will be on. It will even have quantum computing. It will have data science. We may also talk on, if you want. We can also talk of how to crack higher end placements. We probably will have one session on that also. How to crack higher end placements. And we will also cover that with the coming of chat GTP, how will the careers be impacted, so on and so forth. We want to talk to the students also to dispel their doubts and their apprehensions that chat GTP might take over, and maybe there will be very less jobs available for the students. So there are certain fears in the mind of the students. We'll try to address that. And and I mean, once you become a partner, when we can do workshops, and then finally we are sending you the certificates, the posters, e-posters. If you want us to send the physical poster, please do write to us. And if you think there is a centralized body in your college which does this particular activity and they are the right person, kindly show us the light so that we are able to reach to the right person in your college, and we are able to give the poster to them and they percolate it on the WhatsApp group, right? So all in all, we will definitely write to you on what dates we are starting with the new faculty development programs. Want all of you to become our partners. We can have local partners, we can have regional partners, we can have area partners. Encourage more and more faculties to come and study with us. In case you found the if you found the delivery to be good and if it was a good and a learning experience for you. And thirdly, like what's like you do a we do a workshop for your students, and fourth is the summer training program. So from all of us I believe it would have been a lovely learning with Shubhendu. He's a very hands-on guy. And a special thanks to GH Raisoni College, Nagpur, who have been our partner in this particular faculty development program. And we have been able to reach a very good number of more than 500 participants joining this particular faculty development program. And we look forward for the support from all the other colleges also. So we will share the schedule with you of all the upcoming FTPs on the WhatsApp group itself, along with the dates and the joining links. We look forward for your kind this thing. We are happy that most of the people in the faculty development have taken keen interest and the way they have learned. So on behalf of EICT Academy IIT Kanpur, Dr. B.V. Fani, the Chief Investigator for EICT Academy IIT Kanpur, he's the head of the IMA department at IIT Kanpur, and Dr. Amit Karkare, he's a senior prof in the CS department. He's the co-chief investigator. From both of them, on behalf of both the team members, I thank you all, sincerely thank you all for, we'll do that. Please, we'll definitely provide, we'll provide it in the, आपका उसमें ही, जो आपका WhatsApp group है, उसी में ही we'll try and share that. We'll definitely share it. And do not leave the WhatsApp group because there are a lot of things which we share there, and it is going to be. I believe we have already shared the WhatsApp with all of you. Have you all received a WhatsApp from our side with the summer training program poster? Have you received it? We have sent it to everyone about an hour and a half back. We have sent it to everyone. If it has not come, it may come. If it has not come, we'll try and send it to you. Please help us to reach out to the students, and we look forward for your suggestions. My name is Mukesh Kumar, and you can write to me at eict@iitk.ac.in, and we will definitely look forward to meet you again in the subsequent faculty development programs. So from all of us at the ICT Academy, IIT Kanpur, a big namaste and Jai Hind. Thank you very much. Shubhendu, you can please carry on.
Thank you so much, sir. And thank you so much for the lots of appreciation. And let's continue the session. And right now, we are move forwarding towards the IoT that I already promised you that we are going to get a quick revision to build the IoT hardware. So right now, before we are going to close this session, let's build up something that I bring for you. So let's do it. So what I'm going to do, I'm going to share the screen and we are going to build the entire setup of the IoT once again with 4 data stream channels right now. Let's do it. So what we are going to do right now, we are going to get the setup. So first of all, I'm going to give you the username and password also. So don't worry about it in chat box. I'm going to drop the username and password. I'm going to give you a quick review of the step that we need to perform. I hope everyone can understand how to create the account in Blinky Cloud. We don't have much time right now, so I need to make it very quick. I am going to give you a quick revision that how we can build it. First of all, we need to access the template. This is the template format. We have to access it. That's it. So right now we have the template. You can go for a new template also, and you can use a old template also. That's on you. In template, we have to select the data stream. I hope you can see this on the screen. That is the data stream. We have to create the number of data stream. Listen up very carefully. If we are using 4 devices and we need to control the 4 devices, we have to use 4 data streams so that we can operate 4 different channels. Similarly, if we want to create a channel for 5 different devices, or 5 different communication port, we need to create 5 different virtual pins over there. That's it. That's what we want right now. So let's do it step by step. I'm going to tell you. So right now, what I need to do, I need to start the developing virtual pin. So first of all, if I'm talking about this is the first virtual pin. So I'm using bulb. So it is going to be B1, for example. The name of the virtual pin is V0. Data which we are using is integer because we are working on 1 and 0. That's it. We don't want get any decimal numbers. That is why we are not using the double. And similarly, we don't use the string because we are not exchanging any kind of alphabets over there. And unit is nothing. Minimum is 0, maximum is 1, default is 0. So now what we need to do, save. The first virtual pin has been created. Similarly, now we need to create some more data streams. Now, again a virtual pin. This is for the bulb number 2, name V1 and integer data type 0 and 1. That's it. Again, create. Then this is for bulb number 3. Everything is set up, no problem, just go for it. And we have 4 different devices, so we have to go for 4 different virtual pins. We established all the 4 virtual pins. That's it. That is the most fastest way you can do. If you want to put some gauge, if you want some data which has to be come from your node MCU to the cloud to represent some kind of temperature data, humidity data, and these kind of data, on that time, what you need to do, you need to go for one thing that is double so that you can get a decimal values. Thank you so much for the lovely comments, everyone. Thank you so much for the lovely comments. All right, so next we have to move forward for the dashboard. This is the dashboard. I need to delete the old widget, and now I'm going to put the different switches. This is my switch number 1 I need to put over here. This is switch 1, switch 2, switch 3, and the last one is switch 4 right now that I placed. Switch has been put over there. Now what we need to do, we need to do one thing, that in settings I need to set the data streams. This is the V0 data stream. I need to go for it, and I need to just save the set like this. Now this is B1, means for bulb 1. Similarly, I need to go for bulb number 2, save it. Again, go for the bulb number 3, just save it, and again for the bulb number 4 and save it. All the switch has been lock and load for us. Data stream has been fixed in it. Done. What we need to do here, just go for the save and nothing else. It is saved, it is done. Now we have to put the device in online mode. So just go for this option where we need to set up the template so that the template can run in cloud. What we need to do, we need to go for the new device option over here. When I'm pressing the new device option, I need to go for the template. When I'm clicking on template, I need to choose which template I'm going to use. I just built IoT test. IoT test template I created, and now I just need to create it. Now you see the template has been created. Now what I need to do, this is the authentication token that I want to copy. I just click on it, the token has been copied. But in somehow if you miss it, don't worry about it. The all information is representing over here. Now you see device information. In device information there is the authentication token. You just click over there and you got the authentication token easily. So we need the dashboard and these switches. That's it. That's all. Let's go to the Arduino programming section. So let's move forward the Arduino programming section. This is the Arduino programming section. I already sent the programming part to the team. After the session, they will send it to you. And now I need to paste the information at the code so that the authentication token can be connected to this program. Okay, and now the program is able to connect with the cloud system. That's it. It's very simple. Okay, and one more thing, if you want a quick review, these are the participants speaking to English. Okay, these are the authentication tokens. This is the version representing. These are the file which is going to represent that Blinky is going to turn on. These are the header files that we are using 8266 library right now. This is for the Blinky library. And now we are defining that we are using D0, D1, D2, and D3. D5 is still blank because we have only 4 devices to run. Then this is the authentication token which has to be sent to the cloud. And these are the Wi-Fi credentials, that the username and password of the Wi-Fi. That's it, simple. And this is the portion of the code which is going to tell that this is the data stream for V0. What data is coming from V0 is going to read by the param function and tell to the value. And according to the value, we are going to judge it. That's it. Similarly, V0, V1, V2, V2, V3, all the thing has been established like this. Okay. So now what we need to do, we need to upload the code into the node MCU. So let's do it. So what I'm going to do, I'm going to connect this data cable to the node MCU. Before I'm connecting this, let me show you the port is not visible right now. There is no port COM7 which I'm using for node MCU. So let me connect the node MCU first, then see what will happen, what port I am having over here. So now I connected the port. Now let's see what port I am having. So now we see the COM port has been appear, means my node MCU is established a connection with my software, with my computer and software. Now I can upload the program. So what I'm going to do, I'm going to start uploading this program. Meanwhile, the program is uploading. I'm going to send you the username and password. Just give me a second so that I can send the username and password to you. So there it is. Where it is gone? Okay, there we go. So this is the username. I'm just going to send it on your chat box. This is the username right now, and this is the password. There we go. All right, the username and password has been sent to you. Now you also can operate that device from your own end. So now what I need to do, I need to go to the, just give me a second, I need to stop the screen sharing and go back to the this set. All right. So what I need to do, I need to power on all the hardware devices first. So what I'm going to do first, I need to give the power over here, and then I am going to do one more thing, is going to put the power lead over there. There it is. So now we are going to able understand how it is going to work. Just give me a second. I think someone is already operating the devices. Just give me a second. I need to put all the things one by one. So let's see. If I'm pushing this button, now you see this is go start glowing. If I'm activating this one, so what will happen? It is going to start glowing. Okay, I hope now you can see it more clearly. So there are two device has been activated. Now you see I just activated the third one, and now I am going to activate the fourth one. Okay, so what I'm trying to represent you, now you see I'm closing it one by one. All devices I can close like this, even though it is going to represent that we can operate multiple different type of devices. I'm using bulb, you can use fan, you can use air conditioner, you can use any kind of electronic gadget that doesn't work on smart operation. So you can put these things over there and the smart operation has been done for you. Okay, that is the point of the IoT I need to prove. So what we are doing, we are operating multiple devices in the same time. That was the point I need to show you. I think there is a link for you. Kindly share the valuable feedback. The feedback form is available over there. And that's it for the session. And I hope you get, I think someone is writing something. No, that is the feedback form is available over there. And I hope you get some information, informative information over there. And that's a lovely session. Thank you so much, everyone. And I hope we will conduct some different sessions with some different technologies also. I think someone is operating something. Okay. Yeah. Okay. You can operate that. All right. So, so attendance, can we share, can you share email ID? You can send the email on the official mail that will be transferred to me. Means you just mention me over there and the information will be transferred to me. Yeah. Okay, so this is the setup. You can operate from your own end. At the end of that, really great request, and thank you so much. Thank you so much, everyone. That everyone can build these things. They actually, this is the leading technology we are talking about right now. So if we are doing a long session, then we can understand how we can create our own cloud. And I don't know about the video recording right now. You have to discuss with faculty members. Thank you so much, everyone. And now you can operate these things from your own end. So I think that is one of the cool thing of the IoT, that you can operate from your own side. So study contents. Yes, the study content will share soon. Means the session is over right now. So the team will send the study material to you in a WhatsApp group or email. So yes, that is the thing. So can I leave? Okay, okay, you can leave. Thank you so much, everyone. So really, very good. Thank you so much. Thank you so much. Thank you so much. So, all right. I hope you enjoy this session. And the most important thing, that I hope you learned something from this session. So, best of luck and best wishes for the future. And thank you so much, everyone, for showing